I would like to welcome everyone to Flexera's Energy Workshop describing our Storm Guard design options. This educational seminar provides some insight into the available weatherproofing options available for your home and energy systems. Planning for severe weather events starts way in advance of the next severe storm. If you already have a renewable energy system, planning on a new investment, or just want a lightning suppression for your house, the time to act is now. Hoping the next storm won't strike home is not really an option. The three Flexera designs covered by this seminar are the following: lightning and high voltage suppression, standalone battery backup systems, and solar plus battery backup systems. As an electrical design engineer, I have studied many lightning arrestor type products, but never found any living up to the task. Recently, I have been introduced to a new product which has been UL tested to handle the task of containing the amount of energy found in lightning. These products were designed to specifically protect the expensive electronics and equipment found in solar PV systems, but will also protect the wiring in your home and at least minimize other electronic device losses. Flexera's designs, which include lightning arrestors, always include protection for both the AC and DC wiring to cover all solar components. This drawing shows all typical lightning entry points on the DC side of a solar PV system. The DC equipment is located closer to the actual panels and the equipment found in the array. By mounting the surge arrestors near the array, any energy from the strike is safely diverted to earth ground. This energy would normally travel through the wires, down to your solar inverter, and into your house. Another surge arrestor is placed near the inverter on the DC side to contain any strikes which could enter the wires between the panel and the inverters. But this is normally added to the ground mount systems, which has a greater distance between the panels and the inverter. The AC side protection is typically installed very close to the service panel for your house. The service panel is the central hub for all the wires in your house, the connection point for your solar inverters, appliances, and all electronics. Having the surge arrestor near the service panel stops the high voltage strikes and channels the energy away from your house to the earth ground. Most lightning damage to houses and the equipment contained in the house is not from a direct lightning strike, but rather strikes located up to a mile away. Moving on to our standalone battery backup system, I would like to first start out with the traditional AC network configuration for residential buildings. Typically, the utility company connects to an electrical meter mounted on the outside of your house. The meter is directly connected to the service panel or circuit breaker panel. All the AC power wires in your house come from the service panel through your walls and floors to your appliances and other electrical loads. Good so far? Well, when the power stops flowing from the power company through your meter, everything usually stops in your house. Well, this new picture shows a Flexera designed battery backup system. Let's discuss how it works. We actually create a second mini AC grid in your home by adding an emergency load service panel. Through an interview process with the homeowner, Flexera moves critical loads like refrigerators, some lighting, and pumps onto the new critical load network. All loads that are not critical remain on the original service panel. We then connect the critical emergency load service panel to the primary service panel through an emergency inverter system. Your new mini grid is indicated by red wires in this drawing. Now, when the utility company stops sending power, the emergency inverter notices the lack of utility supply power and starts supplying power to the critical load grid within a half a second of power loss. The emergency load inverter will continue to supply power until the batteries run out. The battery sizes are very configurable and can be sized to run your emergency load for any number of days. When the power is supplied by the utility company, the emergency inverter starts to recharge the batteries for the next power outage. Taking what we learned from the standalone battery backup system, I'm just going to add the typical solar system to the drawing. If you are out of power for many days, this is the option to get you through the storm. By adding the solar to the system, the batteries can be charged during the daytime hours or be used to directly run your appliances. If you are not using your solar energy during a power outage, the emergency inverter charges the batteries with it. When the batteries are charged and the utility company's grid is connected, the solar energy is directly net metered back to the utility grid as any other grid-tied system works. The only difference between this system and a traditional grid-tied system is it keeps running when the utility power goes down. Storm Guard systems are only brought to you by Flexera. If you want to learn more about these systems, please fill out a contact form on our website. I would like to now thank everyone for listening to our seminar.